So, have you ever really thought about what happens to that little vial of blood after you leave the doctor's office? You've probably heard of a CBC, a complete blood count, but what you might not realize is that there are two totally different ways of looking at it. It's kind of like the difference between a quick sketch and a super detailed map of your health. Let's unpack that.
We've all been there, right? A little pinch, a vial of blood is drawn, and then you just wait for the results. But what's actually going on behind the scenes? How does that blood sample turn into answers for your doctor? Well, the process is way more fascinating than you probably think.
Okay, so a huge piece of the puzzle in any blood test is your white blood cells. Just think of them as the frontline soldiers of your entire immune system. And by counting them, doctors can read a story about what your body's fighting off at this very moment. Right, so if your white blood cells are this army, your doctor is kind of like the general who needs a solid head count. Are there enough troops on the field? Are they the right kind of troops for this particular battle? Well, it turns out there's more than one way to count this army, and that's where things get really interesting. First up, let's talk about the most common method out there, the three-part differential. This is the absolute workhorse of routine blood tests. It's used in clinics all over the world, every single day. To make this super clear, let's think about laundry. Yeah, laundry. Imagine all your white blood cells are just a giant pile of dirty clothes. A three-part count is basically like sorting that pile into three simple groups: whites, colors, and darks. It's not fancy, but it's fast and it gets the job done for a quick overview. So in medical terms, what the machine is actually doing is sorting your cells into three buckets based almost entirely on their size. You've got the small cells, the lymphocytes, the medium-sized ones, the monocytes, and then all the big cells just get lumped together into one giant group called granulocytes. Simple, right? But what if the clue your doctor needs is buried somewhere in that big pile? Exactly. That's the big question. What if it's not enough to know you have a lot of darks in your laundry? What if you need to know if those darks are t-shirts or heavy winter coats? Lumping all those large cells together, well, that's the major limitation of this test. So, how do we get more detail? Well, that brings us to the more advanced method, the five-part differential. And this isn't just a simple head count. Think of it as a detailed census of your entire immune army. Let's go back to our laundry pile. The five-part test doesn't just make three messy piles. Oh no. It sorts every single item. It knows the difference between t-shirts and jeans, socks and towels. You get a much clearer picture of what's actually going on in there. And this is where it gets really cool. Remember that big granulocyte pile? Well, the five-part test breaks it down into its specific cell types. Suddenly, we can see the neutrophils, which are crucial for fighting bacterial infections. We see the eosinophils, which can point to allergies or even parasites, and the basophils, which are linked to inflammation. Each one tells a completely different and way more specific story. So you might be asking, how is that even possible? How can one machine see five types of cells, but the other only sees three? Well, it's not magic. The secret is all in the technology. The three-part analyzer is really straightforward. The technology it uses basically just measures the size of each cell as it zips past a sensor. Big, medium, or small. That's pretty much it. But the five-part analyzer, whoa, it's on a whole other level. It doesn't just measure the outside, it actually uses lasers to look inside the cell, checking out how complex its internal structure is, things like the shape of its nucleus or how grainy it looks. Let's put them head to head. The three-part test uses something called electrical impedance. You can think of it like a toll booth that only measures how long a car is. Simple. The five-part, though, uses flow cytometry. This is like a high-tech scanner at a customs checkpoint. It measures the car's length, sure, but it's also using lasers to see what's under the hood and how many passengers are inside. It's gathering way more data on every single cell. Okay, so if the five-part test is so much better, why doesn't every single clinic just use that one? This is where the real-world trade-offs come in. It really boils down to a classic battle: cost versus clarity. Get a load of this number, up to 30%. That's the percentage of samples from a three-part analyzer that can get flagged. A flag basically means the machine threw up its hands and said, "I'm not sure about this one." So a human lab technician has to step in and manually look at the blood under a microscope to figure it out. And that, of course, costs a lot of time and money. So here's the breakdown. The three-part analyzer is way more affordable, and it's fantastic for routine checkups in smaller clinics. but it comes with that high rate of manual reviews. On the other hand, the 5-part analyzer costs more, but it's absolutely essential for hospitals dealing with complex cases. And its lower flagging rate, we're talking maybe 10 to 20%, can actually save a ton of labor in the long run.
All right, so we've looked at the cells, the tech, the pros and cons. What's the real takeaway here? What does this all mean?
Here's the bottom line. Neither one of these tests is bad. It's all about using the right tool for the right job. The 3-part test gives you a quick, broad stroke sketch of what's going on, perfect for a routine physical. But the 5-part, that gives you the detailed, color-coded map you absolutely need when you're trying to diagnose a complicated or mysterious illness.
And that leaves us with one last question to think about. We all know technology never stands still. These advanced laser systems are getting smaller, faster, and cheaper every single year. So you have to wonder, will a day come when that super detailed map is just as easy and affordable to get as the simple sketch? And if it does, what could that mean for the future of medicine? Definitely something to think about.